Hello, everybody. Morning, afternoon, evening, as the case may be. My name is Shruti Kulkarni. I am an information security architect with Alexon. I'm also a volunteer at Cloud Security Alliance, and I am a co chair for the data pillar and the application pillar and identity pillar within the space of Zero Trust Working Group. Today, my presentation is going to be about using Zero Trust to secure enterprise information in large language model environments. So, this is going to be our agenda. We're going to talk about the context and the objectives for this presentation, the large language model environments, organization data, then the need to secure LLM environments, some nuances about LLM environments, threat scenarios, and how to secure LLM environments using Zero Trust. And finally, we have some conclusions for you. I'm going to start off with the context and the objectives. Large language model environments are on the rise by businesses to process their business requirements. Large language models offer a lot of advantages and business benefits. For example, they can process high velocity of data, large volumes of data, can provide pattern matching, and lead to use cases wherein automations can be achieved at a greater pace. Patterns can be matched for sales requirements that lead to leads for sales. And then, of course, there is also the use case for pattern matching and for business analysis, etc. Now, with the increasing use of LLM environments, of course, there is also the risk of data that is being used in such environments being compromised. Risk of compromise of data is nothing new. It's there for most environments. However, when a large language model environment is being used, there are certain nuances which an organization may want to keep in mind and consider this environment as a part of their security processes. For example, if the organization is into conducting threat models before using an emerging technology like LLMs and AI and ML, it's always good to understand the risk of data being compromised in such environments. Data could be exfiltrated, poisoned, unauthorized access. They all hold good for LLM environments as well. There's a bit of a background to why I'm doing this presentation. We have produced a deliverable called Using Zero Trust to Secure Enterprise Data in LLM environments. And it actually started out when Jim Reeves presented this idea. And then, of course, again, as I said, it led to a research paper using Zero Trust to secure enterprise information in LLM environments. And it is actually the content of this paper that I'm presenting in this presentation. So the objectives of this paper include, and obviously that extends to this presentation as well, it's the view of large language model environments from an organization perspective. And the data persisted in SaaS environments and self-hosted environments from an LLM environment perspective. And then using LLM environments safely and securely. So before we start off on the actual presentation, I just want to bring your attention to the environment itself. So when we say large language model environment, what does it really comprise of? To have a model environment, we need to have models. That goes without saying. And then, of course, we need typically and generally, we need LLM datasets for training these models. Also, models are used with datasets in many organizations and in many use cases to process information, to obtain business outputs, be it as a chatbots retrieving responses from a backend, or pattern matching, or log analysis, be it anything. So models are required and datasets are required. And I'm talking about general use cases, not about any specific or edge cases. These models are installed in an environment because obviously they cannot run in vacuum. And the environment comes along with infrastructure, network. So this is the environment. And of course, when we have got this environment and we have a business use case, there is always the end user who would like to view the outputs of the models, for which an application layer is usually used, through which the end user would enter a prompt and the results are obtained. The outputs of the model processing are obtained and presented to the end user. Now, this is a general scenario. In some specific cases, organizations may want to sync their LLM datasets with an on premise database. And this is assuming that the LLM environment is not self hosted or is actually hosted in a separate environment to the on premise database. So, in such cases, there would be a requirement of an integration layer, which may be provided by technologies like Kafka or Confluent Cloud. So please have this in mind when we go through the presentation, because a lot of our slides are related to this diagram. This slide actually presents the same layout in a different format. As you can see, it's a layered architecture. So you've got the data sets and the data inputs, which is the processing layer. Then you've got the integration layer, which can be integrated, which provides integration between on-premise and LLM environments. And then you've got the models and the algorithms, which are the processing layers, which act upon the data sets and then present the outputs. They all have supporting infrastructure like the environment, infrastructure, network connectivity, and the results of all of this is presented in the application layer to the end users. When we are talking about organization data, there are different types of data that is used with training models and in LLM environments. There are various types of data that are used, data that is used to train the models, data that is used to validate the models, fine tuning of data. Then you have RAG, which actually integrates with external knowledge databases. And then you've got model hyperparameters, and more importantly, user session data and the log data. So, in case end users, employees of an organization use an LLM environment, their user session data is persisted, and also the log data of the recorded data on the events and the interactions with the model's operation. Now, why are we talking about all this? And why do we really need to secure LLM environments? We saw in one of the previous slides the spatial layout of an LLM environment. Now, what happens is that when the users are on corporate laptops or desktops, corporate devices typically, there may be organizational controls applied on those devices, which may prevent an employee from interacting with an AI model or an LLM environment, which may be deemed insecure by the organization. Every organization operates differently. However, there's nothing stopping an employee from unknowingly entering organization data from a personally owned device. And this could be more pronounced where BYOD is a regular theme, but is not really governed. So, unknowingly, when an employee contributes to the training data, the enterprise data may be leaving the organization. Then, of course, there is always a risk of data sets being poisoned. Now, when I say it's a direct impact, we all know that malicious actors or threat actors may laterally move into the environment, try to either exfiltrate data or try and compromise the integrity of the data or poison the data sets. When poisoned data sets are used, they may actually lead to incorrect results for the very business process where LLM environments are being leveraged. And the second one is if a threat actor or malicious actor poisons the models. So that's another impact which has on the processing of the data by leveraging LLM environments. Now, here we have got to consider two sets of actors. One is a threat actor or a malicious actor who may move laterally or may try to compromise the data using various other data compromise techniques and poisoning the models. But the second actor is an innocent employee without knowing contributing to either poisoning of data sets or actually contributing to exfiltration of data from the organization. So we need to consider both aspects of the malicious actors. Now, what this actually leads to is exfiltration of data. Also, it leads to organizational data residing in some other jurisdiction. And there are other impacts as well, which we will see in the coming slides. But before that, let's look at some nuances of LLM environments. So when LLM environments are self-hosted and the organization, uses self-hosts the environment in their own data center, then there is the data resides in their own jurisdiction or in their own ownership. There is no third party access or third party angle to this data. However, if organization data is used as prompts in SaaS LLM environments, then there is always a question of who owns that data. The SaaS vendor has provided the platform. It could mean that the SaaS owner owns the data and any outputs of the processing of the data. But what is the impact? The question that we need to ask ourselves is what's the impact it may have on the organization itself if the data that it owns business wise is also being owned by a SaaS vendor? And also, data jurisdiction plays a big part. Now, what if SaaS implementation has their data sets running out of jurisdiction which may not have the same kind of rights and freedoms of citizens as the jurisdiction of the organization? So, those are the points that need to be considered for LLM environments. Then there are the architectural decisions, which is an interesting one because, for example, if an organization decides to use their HR data in LLM environment, what happens then? A malicious actor could actually search for their manager's salary, a malicious insider, or a curious insider as well. This may not be a malicious intent when someone searches for their manager's salary or a co-worker's performance results or someone else's PII data. Now, the problem with this is the prompts can be manipulated using jailbreaking techniques, and the user may try to extract this information. Now, the question that we may ask is why not actually implement access controls and everything so that the processing does not present data that is not a need to know basis? However, if we implement a lot of controls and everything, it may lead to denial of service because you see the security controls come at a cost and sometimes they may be performance related costs. And in a genuine case, the data may not be presented to the user on right time because of passing through so many controls. So just a point to be thought about. And then, of course, there is also using models along with datasets and pickle files where users may want to persist data output and in memory, serializing, and then retrieve it using deserialization so that they don't have to run the model again and again. Now, what if the pickle files that you have obtained from a third party contains malware? So that's to be thought about. Can that be scanned? Can that be actually evaluated? Just bring some thought processes out there. Now, of course, there is the next step about having shadow AI, agentic AI, and MCP. All of these use cases are quite challenging to monitor sometimes, and then there may be prompt injection amplification, data flow security, etc. So supposing there is a developer in your organization who is very curious and wants to know how to process a particular data set for a business use case. Now they may actually connect to the on-premise database using a connection string obtained from the database administrator. Now, if this connection string is persisted in the clear on the developer's laptop and there is a malware attack, then there could be a compromise. In the grand scheme of things, they all tie in together. So it's always good for organizations to understand shadow AI exists and also to provide the right kind of guidance and training to the developers and the right environment, of course, because everybody's curious. They want to learn, they want to know. So it's better to give a controlled environment for developers to try it out rather than having shadow AI. I'm just bringing this up my diagram again because we are going to talk about the threat scenarios for each of these layers. Most organizations have enterprise data, so there will be threats to the enterprise data. And these threats include data poisoning, inadequate monitoring and weak access controls, capabilities of solutions that are missed in solution architecture. For example, the kind of HR data I mentioned earlier. If your organization data is so very sensitive or the business process is so very sensitive, then you may want to have a hard think about whether you want to use that kind of system along with LLM environments where there is a risk of data being shared which is not aligned to need to know basis or least privilege. Then there are supply chain vulnerabilities and lack of shared security responsibility execution in SaaS environments. So, what are the impact of this? Incorrect processing and results may lead to the defeat of the business requirement for which the LLM environment was especially set up. This could lead to unauthorized access. There could be data exfiltration and then supply chain attacks, with poisoned crowdsourced data sets or insecure pre-trained models. Then there are threat scenarios from models themselves, when using poison models, supply chain risk with typo-squatted libraries, prompt injections, failure to comply with legislative regulatory frameworks may take place. And the impact of this is again incorrect processing and results. Data exfiltration if malicious code is embedded in libraries, bias and hallucinations, and compliance breach, for example, EU AI Act and the National Artificial Intelligence Initiative Act of 2020. Then there are threat scenarios from application layer and APIs. These again are prompt injections, phishing of AI-based applications and products, lack of security hygiene by SaaS product owners, and the reliance on third-party plugins, datasets, models, and libraries, and embedded pipeline and vector database flaws. The impact of this is unauthorized disclosure of information, which is quite a common theme running around with a lot of threat scenarios. However, with threat scenarios from application layer, if a threat actor manages to run a lot of queries in an unprecedented short time, it could lead to excess consumption of resources of the backend systems because all the models that need to retrieve data or to process data or to pattern out data, to do any kind of analysis would need resources and processing. Then, of course, there is always the risk of incorrect information being served to the end users, and then compromise of credentials through brute force attacks, session related attacks, using jailbreaking techniques, etc. Then there is the threat scenarios from infrastructure layer, which is quite common across a lot of environments. This is not specific to LLM environments. It's mainly due to lack of infrastructure hardening, lack of network segmentation, insufficient monitoring of file uploads, which could lead to unintentionally exposed services or open ports, vulnerabilities in devices exposed to a public network, lateral movement, malware injection, etc. Then there are the threat scenarios from integration layer. So especially with integration layer, if the database connection string is a misconfigured between test environments and production environments, that could again lead to incorrect data being processed and presented to the end user, and also leakage of credentials and sensitive enterprise data in different environments, which the organization may find it difficult to control. So whatever threat scenarios I presented so far, they have a basis. So there are real life incidents that have taken place with LLM environments. So while threat categories may seem abstract, real world incidents show how these risks materialize in practice. So this is from Slack, where information was leaked via prompt injection. Amazon warned employees not to share confidential information with ChatGPT, and Samsung banned ChatGPT, Google Bard, etc. because organizations exercising caution about sharing confidential information on SaaS LLM environment. These compromises are really very tricky and interesting. So a hacker tricked a chatbot into selling him a car for $1. And then Air Canada's chatbot promised a discount, so the airline has to pay. Now, where does the liability lie in such a scenario? And then Alphabet shares dive after Google AI chatbot gave a different answer to what was actually expected. So, all I'm trying to illustrate is that compromises do take place with LLM environments and they need to be secured. So that is where we actually propose zero trust for LLM environments, and our guidance for using zero trust principles is rooted in NSTAC report to the president that was published on February 23, 2022. So here are our guidances for zero trust for LLM environments. That is, using access control, least privilege, and authentication for all the components that are being used in the environment. Applying right level of network layer security, especially in using segmentation of network. And also, there are ways in which you can use microsegmentation at the full stack layer. For example, microsegmentation need not be only applied at a network layer. You can apply it at identity to make sure that if one identity is compromised, that doesn't actually move laterally into other environments. Especially for network layer, can remove inbound exposure by enforcing private egress only, and then make sure that you bind connectivity to verified identities rather than ports or IP addresses. Then achieving comprehensive visibility at application layer by making sure that you scan. Well, this is more of a activity to be done by the organizations that source models. But of course, there's nothing stopping when organizations consume models and make sure that their code behaves as expected, and then making sure that there is proper supply chain risk assessment that is conducted to look for poison models, or when sourcing models, or when sourcing models with trained data, make sure that they are not poisoned or they are not malicious, etc. And then there is another one, comprehensive visibility with visibility and analytics, where one can actually monitor for any kind of data that is exfiltrating their environment, ensuring that any data that has egress, where there is no egress required. So if there is no egress of data required, block that egress, or monitor if there are any connections made to personal cloud environments or personal cloud storages, etc. Then, of course, there is the logging and monitoring, which is a very important component of zero trust, and using that to make sure that malicious activities are identified. And then, of course, there is the governance of secure adoption of LLM environments and output validation and LLM environments, and using entitlements. Output validation can be done using boundary conditions and looking for typing, etc. And also, when data is presented to the end users, making sure that they match the entitlements and not just present data to anybody, thus violating the need to know basis. So, again, I come back to the same point. These are applicable to all these environments. For example, least privilege and access control and authentication applies to people who are accessing datasets, people who are operating models, people who are administering infrastructure and network, people who are actually enabling the integration layer, and people who are building the application layer by ensuring that output data is matched to entitlements. Now, we have other references as well, along with our NSTAC report. So that is OWASP top 10 risks. Then there is the regulatory guidance and legislation. And there are a lot of CSA AI references. We invite you to go and have a look at all of these other references as well. Along with the zero trust guidance I provided in the previous slides, there is also a specific zero trust IAM guidance for AI, that is managing and authenticating human user identities while using AI products, and managing and authenticating agentic AI and non-human identities, and access control and authorize AI, because any of these going wrong can still lead to compromise of enterprise data in LLM environments. And then, last but not the least, is the human element. Employees using enterprise data with AI services like ChatGPT can enter sensitive information into prompts, and these can only be mitigated with education and training. Services, as I mentioned earlier, ChatGPT and such like can be accessed from personal devices outside of enterprise network. It's very important for the organizations to train and educate their employees to not use organization data with such ChatGPT and such services. You can have more information about human element from this CSA publication. Now, this is what I have for our presentation, and here are my conclusions. So, significant opportunities are made available for enterprises with LLM environments, but these should be considered with risks impacting security, compliance, and trust. To address these challenges, and organizations can choose to adopt a zero trust model right from the beginning and then ensure that LLM integration is not only effective but also secure, resilient, and aligned with the organization governance requirements. And here is the link to the paper. I hope you will all come and review our paper, read our paper, and let us know what you think about it. And this is all I have. Thank you very much.